Okay, so solving a system of equations using Gaussian elimination is basically just like using regular elimination. It's just a little bit more organized, and your goal is a little bit different. You want to get your system of equations into this stair-step kind of form where your bottom equation just has the final unknown and it's solved. And then the second equation has the unknown before that and the final unknown and a constant, and then the top equation has all three unknowns and a constant. And so you're trying to get it in this stair-step form because that way you can use back substitution, because you know what z is, so you can plug that into the second equation and find out what y is, and then you can plug y and z into the first equation and find out what x is. So it's this kind of stair-step arrangement that you're trying to get, because this system of equations right here is already in what we call row echelon form. So you've got z equals 2, so you take that 2 and put it into the second equation. So you'll have y plus 3z, which is 2, equals 5. So y plus 6 equals 5. So y is -1. You're subtracting 6 on both sides. Now that you have y and z, you can plug both of those into the first equation to get x. So the first equation, x minus 2y, y is -1, and then plus 3z, z is 2, and that's supposed to equal 9. So x plus 2 plus 6 equals 9. So x plus 8 equals 9, so x equals 1. So you have all three unknowns figured out now. 1, -1, and 2. So that's your solution. So if you have your equations in this row echelon form, it helps you be able to find the solutions quickly. So Gaussian elimination allows you to do these rules. You can use these rules, which are called elementary row operations. You can do any of these three things in order to get your system into row echelon form, into that stair-step form. You can interchange two equations. You can multiply one of the equations by a non-zero constant, and you can add a multiple of one equation to another equation to replace the latter equation. All right, so I'm going to skip the 2 by 2 because you already really know how to do that. Let's look at this 3 by 3 system and solve it. Okay, so the first thing we're going to do is just make sure that everything is lined up so that your x's are in one column and your y's are in the second column and your z's are in the third column, and then your constants are in the final column. So we'll just rewrite it and line everything up. So -x plus 3y equals -4, and then 2x minus 5y plus 5z equals 17. Okay, so you've got everything all lined up. All right, now you can call this row 1, row 2, and row 3. I'm just giving them names so that as we do operations with those rows, you'll know what we're doing. All right, so first of all, you can add the first and second equations together, and it will cancel out the x in that second equation. So that's one thing you can do to get started here. So that's what we'll do. We'll add R1 plus R2 for our first step, and we'll replace R2, okay, the second equation, with our sum. So we're not doing anything. The first equation stays the way it is. We're not replacing the first equation. It stays the way it is. Second equation is going to become this, the sum of the first two equations. All right, so I'm going to add the first two equations. X plus -x is 0x, so there's no x term. -2y plus 3y is just plus y. And then 3z, if you add 3z plus nothing, you get 3z. And that equals 9 minus 4, which is 5. Okay, so we replaced the second equation with the sum of the first two equations. X plus negative x is 0x. Negative 2y plus 3y is y. 3z plus nothing is 3z, and 9 minus 4 is 5. So that replaces our second equation. The third equation stays the way it is. Okay, so we have gotten rid of one of the things in the first column. So we're trying to empty out that first column so that we'll have this stair step coming down. Ugh, my pen's not working. No, that's not why. Okay, so we want our columns to look like this. So we want all this stuff down here to be empty. So we just want we want the first equation to have all the unknowns. We want the second and so on, the following equations, to not have that first unknown because we want to make this stair step. All right, so now we've still got this 2x in the third equation. We want to empty that out. We want to get rid of that first term there. So we're going to multiply the first equation by negative 2 and add it to the third equation and replace the third equation with that sum. All right, so we're going to add negative 2 times the first equation, so negative 2r1 plus r3, because that way it'll cancel that term, and that's our next step, is to cancel that other first term. We're getting rid of all the first terms. Then we'll get rid of the second term in the second equation. So step by step, we're emptying out those stair steps. All right, so now we're going to multiply the first equation by negative 2 and add that to the third equation. But we're not changing the first equation. It's staying the way it is. All the equations are staying the way they are except the third equation. Whatever is second here, whatever equation is the second one in your sum, whatever you're doing, that's the one you replace with the new equation. All right, so these two stay the way they are. Now, we're going to replace row 3 with negative 2r1 plus r3. All right, so here was r1, r2, r3. All right, negative 2 times r1. So negative 2x plus 2x is 0x. Negative 2 times negative 2y is positive 4y minus 5y is going to be negative y. Positive 4 minus 5 is negative 1, so negative y. Then we've got negative 2 times 3z, that's negative 6z, plus 5z is going to give me negative z. And then 9 times negative 2 is negative 18, plus 17 is negative 1. Okay? So we multiplied that first equation by negative 2, added it to the third equation, and this is our new third equation, negative y minus z equals negative 1. All right, so now we've emptied out this stair step, this first stair step. We only wanted the first equation to have that first unknown. Now, we only want the second equation to have the second unknown, so we need to cancel out the second unknown in the third equation. So let me get some more space here. All right, so that's pretty easy to do. All I need to do is add the second two equations. So I can add r2 plus r3 and replace r3 with that sum, and that will make that will cancel out that y term in the third equation. All right, so the first equation doesn't change. Second equation's not going to change. The third equation is now going to become this sum. The second equation, all right, so r1, r2, r3. All right, we're going to add r2 and r3. So y minus y is 0y. 3z minus z is plus 2z. 5 minus 1 is 4. All right, so we now have this system of equations in row echelon form. There's the stair step. There's nothing under there. There's nothing under there. All right, so now I can use back substitution to find out what z is, to find out, well, first of all, I can solve for z in the third equation. I can multiply that third equation by 1/2 and get z by itself. So z equals 2. 2z is 4, then z equals 2. Now I can plug 2 into the second equation. So I'll have y plus 3 times 2 equals 5. So y plus 6 equals 5. Y equals negative 1. And then I can take z and y and plug them both into the first equation and find x. So I know that z is 2, y is negative 1. So in the first equation, you've got x minus 2 times y plus 3 times z equals 9. So x plus 2 plus 6 equals 9. X plus 8 equals 9. So x equals 1. So the solution is 1, negative 1, 2.